Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study what is the moment of force and its applications. So, the very important thing is that moment of force is so important to understand the concepts of the torque, and which is related to the topic. It is related to the course of strength of materials or solid mechanics and design of machine members, and which is also related to the concept of which is also related to the course of structural dynamics. So moment of force is the fountainhead concept, is the fountainhead of all various courses in the fields of mechanical engineering, civil engineering, and aeronautical engineering. So the moment of force, this is required in order to tighten the nuts and bolts, and moment of force is required in order to opening and closing the doors, yeah, etc. Moment of force is required to open the nuts, to open the screws, or to open the caps of any bottles. So without moment of force, the things can't be tightened and can't be opened, and also can't be opened and can't be closed. So if you understand the deep meaning of moment of force, otherwise without applying the proper moment of a force, the things, suppose in the case of nuts and bolts, moment of force is required to tighten the nut of a wheel, four-wheeler, or when the tire, if you want to fit, those are nuts and bolts mechanism. So this moment of force is highly required in order to avoid the disturbances, or in order to avoid the damages of integral parts of a structure. So what is the moment of force? When will it occur? So now moment of force also comes into the picture when the coplanar parallel force system. If you want to find out the resultant of a coplanar parallel force system, this moment of force is required. So moment of force concept also required in order to balance the system. In order to balance, in order to apply the force or apply the load, where, at what distance, at what force, how much force, at what distance, all these questions can be answered by using the concept of a moment of a force. So with this, we'll understand that when will into the picture here. In this session, we are going to study the moment of a force comes into the picture when the parallel forces are acting on a system. Want to find out the body should be in equilibrium momentarily. That is called momentum equilibrium. We will apply the momentum equilibrium equation, that is the sigma h, sigma m equal to 0. What is that sigma m equal to 0? Algebraic sum of all moments about an arbitrary point equal to 0. So what type of movements here? That there are two types of movements. In previous sessions we have studied. One is clockwise movement, another one is anti-clockwise movement. Here, when moment of a force, that concepts comes, application of that moment of force. Let us begin. There are various types of coplanar system, coplanar force system. The coplanar force system is the one of the category of a system of forces. There is a coplanar system of forces, and number two is the non-coplanar system of forces. Again, in coplanar system of forces, there are three categories. One is coplanar collinear system, and second category is coplanar concurrent force system, and the third one is coplanar parallel forces system. Here the coplanar parallel forces, again there are two types are there, unlike coplanar like parallel forces system, and second category is coplanar unlike parallel forces system. So here we are going to study the resultant. If you want to find out the resultant of such coplanar parallel force system, we can't apply the law of parallelogram of forces, and also we can't apply the resolution of the force here. Yes, we can apply the resolution of the force to make it parallel. So the point is that here the parallelogram of forces or parallelogram law of forces can be applied when two forces are acting on a particle. Those two forces are concurrent at one point on your body. That means coplanar concurrent force system. How many forces in parallelogram law? There are two forces has to be acted. Then we can find out the resultant of these two forces by using law of parallelogram of forces. When two forces acts, the effect of those two, what is the resultant force? The effect of the number of forces is replaced by a single force. That single force is nothing but a resultant force. So the number of forces acts with a different magnitude and with a different directions. So those different magnitudes can be replaced by a single magnitude force, that is a resultant force, and the various directions can be represented by a single direction, that is the direction of the resultant force. All right, that is the resultant force concept. So the physics behind this, the physics behind the number of coplanar force system is when number of forces acts. So the effect of those forces is replaced by using the concepts of resolution of a force system. In the concepts of a resolution of a force system, what we will do when the forces acts with some inclination, either acute angle or obtuse angle with respect to the reference axis, those force components can be resolved into rectangular components such as horizontal and vertical components by using again the concepts of trigonometry. That means horizontal components using the cosine theta and vertical components using sine theta. So with reference to the same axis for all the forces. So what we will do here, sigma h equal to, in the coplanar concurrent force system, sigma h equal to algebraic sum of all the horizontal forces, sigma v algebraic sum of our vertical forces. The resultant force R equal to under square root of sigma h whole square plus sigma v whole square. This sigma h and sigma v. So what is the direction of this coplanar concurrent forces system? The direction of the resultant force, theta equal to tan inverse of sigma v by sigma h. In that manner, the coplanar concurrent force system, the resultant force can be calculated for the coplanar concurrent force system. Now coming to the concept of a coplanar parallel forces. For the case of coplanar parallel force system, here what is the coplanar parallel forces? The number of forces acts. The direction of the parallel forces are parallel to each other, which doesn't intersect at one point. So each force meets the body at various points. That is the meaning. Now the resultant of is how to find out such forces. So by using law of moments, the principle of moments. What is the principle of moments? Again, what is the moment comes into that? The moment is nothing but mathematically it is the product of the multiplication of the force into perpendicular distance. Force times perpendicular distance. This d is the direct distance from the action of the force to the point where we are going to take the moment. So what is that here? This is what in the figure 2 and figure 1 you can see. Figure 2 you can understand the direction of the action of the force is F, and where it is, the R is the distance, perpendicular distance from the action of the line of action to the point. The force multiplied by R, that F into R is nothing but the moment of a force. That is mathematically, what is the effect of this moment? This moment causes the rotation to the body. So when the force is acting in this direction about this point, when the force is acting about this direction, about this point, the body, what happens? It rotates. All right. From my direction, if you see the screen, it rotates in this direction. So if we consider the force is pulling the body. So suppose the force here, how the way finger, you can see the finger, it is a rotation. Okay. So that is the moment. The moment causes the body. What effect? Physically, it gives the rotary motion. Understand? So the effect of the moment of force causes the rotary motion or gives rotary motion to your body. That's why when you're pushing the door is here. Yes, if you push the door, it is hinged at one end. If you push the door moves. The door moves. If you see in top view, what will happen? It moves, rotary motion. Because of the rotary motion, it is hinged at one end. This is the point, pivot point. from because of the pivot point, if there is no pivot point, if you push the door perpendicularly, it moves. The linear motion takes place because of not pivoting. If you pivot at one end, push perpendicularly, if you give the force, then immediately it moves. It moves like that. Alright. That rotary motion giving to the door because of the what? Moment of a force. This moment of a force causes to rotate the body. Alright. Here, the effect of the rotation is opening the door. Similarly, the effect of rotation can be tightening the bolt or nut. The effect of rotation can be opening the cap. The effect of rotation can be the rotation effect. There can be what will happen? Opening, yes. If you rotate the body here, you see, it can be opened or tightened. But the causes of opening and closing is what? The force which is acting on the body is the moment of a force. So with that, we started yesterday. And one more thing here, the direction of the moment of axis. This is the O, point O is the moment of axis. If you see the fingers, right hand, and if the direction of the rotation of the force in this direction, these fingers indicates the direction. When the body is, the force is acting in the direction, this is the pivot point, this is the axis, moment axis, the body causes to rotate. If you see in top view, it is in counterclockwise direction. So that's why it is known as the moment of a force causing to rotate the body in anti-clockwise direction, then that moment is known as anti-clockwise moment. If the moment of force causing the body to rotate in clockwise direction, then that moment is known as clockwise moment. Alright? Now, very simple to clockwise movement and anti-clockwise movement. Yes? This is what? One more important concept. We are recapitulating the concept of moment of force more and more to understand the importance of the moment principle, this concept. Now suppose here the door is hinged here at one end. This is the wall, and here it is another wall. The door, it is kept. This is the door. Now the door, what is the force? M equal, what is the moment of a force? M equal to force times distance. The distance where the action of the force to the hinge. This is the D1. And here it is D2. And the force Fr, pushing the force, regular force Fr. The force Fl, larger force. Now, the distance D1 is high. D1 is more. D1 is proportional to when D1 is more. What will happen? The direction in relation to the force applied, F equal to M by D. This F is inversely proportional to D. Alright? F is inversely proportional to D. So when D increases, what will happen? F reduces. When D decreases, when D becomes low, when D is low, F needs more. When D is high, F becomes low. That's what here, when you apply the force near the pivot zone, near the pivot end to open the door, you try to apply it. We need more force or larger force to open, to give rotary motion to the door. And go distance maintain. If you distance more, that is the end of the door, you push. You need less force. I understand why. What is the reason behind, physics behind the moment of a force? What is that logic here? What is the concept? F is inversely proportional to D, where D is the distance, perpendicular distance between the action of the force to the pivot. That's why when D is increases, F becomes reduces. F is reduced. F becomes reduced. The point is that if you want to apply less force to open the door, we have to apply, is this to apply near the door, near the pivot, or is to apply away from the pivot? So better to maintain distance more, enough distance such a way you can apply less force, you can open the door. Okay. Now, sometimes the children open the door, they close the door at the end, near to the pivot end. They try to push the door. The door never opens. The door says, no, 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 I can't be moved. The point is that here, if you apply the door, if the children apply the force at the end of the free end of the door, immediately it can be opened. Alright. So the point is that generally, if the door is having the spring attachment backside, that is means if you open the door, leave the door immediately shuts off immediately because of the backside, the way arrangement, the spring arrangement will be there. For such cases, if you apply the force near the pivot end, never, it need lot of force to open the door because the spring is pushing backside is very closer to the applied force. So the same force, or you need less force to open the door away from the pivot end, that is the free end of the door, immediately you can open, or with less force is required. Because the reason behind this is force is directly inversely proportional to the distance. Alright, now from this figure we can understand how the regular pushing force, generally we have to push the door to open it, and the larger push is required the distance d2. That means if d2 is smaller than d1, that means f2 is greater than, or fl is greater than f1 is required. Okay, now more about the moments. Here the moment is nothing but the force direction to the perpendicular distance. Force to perpendicular distance. If you are applying the force, this is the perpendicular. Understand? Now here in this case, there is F1 and F1 into D. When we are considering the moment of a force, F1 times D, we have to make it, the pivot point is the 2. That is M2. M2 equal to F1 times D. If you are considering applying the force, if you are considering the moment about 1, that means F2 should become, it is making an angle theta. That F2 should be what? Perpendicular. Either D should be perpendicular distance towards that point. Then it is another. Or the F2 make it vertical component. That is F2V. That is F2 sine theta. Then the distance is D. So M1, then M2. Here the moment of force 1 is here M2, moment of the force M2. What is the pivot point? The pivot point becomes 1. Then F2V times D. F2V becomes vertical, downward, and D is the perpendicular distance. D is the perpendicular distance. So F2 sine theta times this D. So what is that F2V? That is F2 sine theta times D. That is M2. This F2 sine theta, what is the theta? The angle. Theta is the angle with which this F2 is acting. So there is another component, that is horizontal component, that is F2H. That is F2 cos theta. This F2 cos theta is acting in this direction. So what is the perpendicular distance? F2H into D. The perpendicular distance is 0. The moment caused by F2H is 0. That means no movement. F2H not at all giving no movement for F2H because the perpendicular distance is the line of action to the distance. So no movement because of this F2H. But there is a movement with F2V, that is called F2V, that is F2 sine theta. This F2 sine theta causing the motion to the body 1 to 2, this portion, which clockwise, is this clockwise or anti-clockwise? In clockwise direction it is moving. Alright, then what about F1V? This F1V, the pivot point is the 2. 2 is the pivot point. This F1 is causing the body, that is the D, F1 into D. This is causing again clockwise. It is clockwise, it is clockwise. Yes, if you make it the center. Alright, this making the center, it is rotating clockwise direction. So circle is clockwise. From my side is clockwise, from your vision, camera. Then it becomes counterclockwise direction. Yes, this is the clockwise for your vision. the clockwise motion takes place. Alright, this is F2 sine theta times d, that is m2. The point is that the concept of the moment can be calculated, or the moment can be calculated if we know the force, the direct action of the force, and the distance should be perpendicular. That is the line of action, the angle between the line of action of the force and towards the point, that distance should be perpendicular. The action of the force should be vertical, then the distance horizontal, then it is 90 degrees should be there. There is 90 degree. So in this case, in this figure, the moment caused by F1 and F2 V is clockwise moment. It is giving the clockwise motion, that means clockwise movement. Or the type of movement given by F1 and F2 V is clockwise motion, clockwise movement. If we consider, as a matter of case study, if we consider F1V is downwards, F1 is downwards, the same F2, point 1 and point 2 is theta. Okay, and let us begin. This F2 is in this direction, this is F2. So it is theta, then vertical direction becomes, this vertical, this becomes F2V, and the horizontal, it becomes F2H. The distance between 2 points is D. Now, the moment of a force caused by F1 force, that is M1 equal to F1 times D. In which direction? It is in counterclockwise direction. If you see from my side here, downwards here, from your side it becomes, the vision is such a way that it can become, yeah. Now, F2V into D, this F2V into D, that is M2 equal to F2V into D in this direction. So, the movement caused by, the type of movement given by this F1, F2 is anti-clockwise movements. The moments caused by F1 and F2 are what? Anti-clockwise movement. So in that manner, now one more case study you can understand. One more case study is that, suppose you may consider, I am considering F1 downward acting upwards, the point 1, point 2, and it is in upward direction. It is theta. Now, if you resolve the moment, the point is that it is F1, it is F2, it becomes F2V theta, and the distance between points 1 and 2 is D. Now F2V equal to F2 sin theta. Moment M1, the moment of the force F1, that is F1 into D. And moment of force M2 equal to F2V into D. What is F2V? F2 sin theta into D. The direction of the moment to F2V, that is F2 is the direction of the moment. F1 is in clockwise direction and F2V caused by F2 force is in counterclockwise direction. It is in clockwise, it is in anti-clockwise. So point is that, what is the motion of your body here if you consider 1 to 2? The pivot here, I pivoted now. Now before that, yes, you can pivot this point and that point also. How it causes to rotate? In which direction it causes? When F1 into D is acting in one direction, F2V into 2 F2V times D is acting, that movement is acting in opposite direction. Now which direction the body is moving? Is this clockwise or counterclockwise? The motion of your body, rotation giving. So it depends upon the magnitude of your force. The magnitude of the force, if F1 times D, the clockwise movement, okay? Or one more thing, very important. I'm going to consider at the midpoint, it is a D by 2 and here it is D by 2. You'll understand better. Now it's the pivot point is O. That means F1 into D by 2, F2V into D by 2. That is, yes, now concept is. Now this is the fulcrum point at pivot point. How the body is being rotated? If F1 into D by 2 equal to F2V times D by 2. Case 1. F1 into D by 2 equal to F2V times D by 2. Then the body will be in equilibrium. No rotary motion. Neither clockwise nor anti-clockwise. Then such body is known as momentarily equilibrium state condition. No motion. If the case 2, if F1 is greater than F2, that means F1 into D by 2 is more than F2 times D by 2. Then what will happen? The body moves F1 in clockwise direction. F1, it lifts. Clockwise motion. Clockwise it comes. The body F1, it rotates in this direction, clockwise direction. And case 3. The case 3 is that if F1 or F2 is greater than F1, if F2 is greater than F1, the body is in which direction? Anti-clockwise direction. So now we have studied 3 cases in this year. Case 1, F1 into D by 2 equal to F2 into D by 2. That means F1 equal to F2. That is the case. If F1 equal to F2, the body is in equilibrium because the D by 2 is same. Distance between the pivot points to the force 1 and F1 and F2 is same. So F1 into D by 2 means it is the clockwise movement. F2V into D by 2 is the anti-clockwise movement. These clockwise movements equal to anti-clockwise movements are algebraic sum of the movements. That means clockwise movements and anti-clockwise movements sum is equal to 0. Then it is known as the principle of movements or law of movements. The law of movements states that algebraic sum of all moments about any arbitrary point equal to 0. That is sigma m equal to 0. What is the algebraic sum? Algebraic sum means the positive in that sum, it can be a clockwise and anti-clockwise movements. If we consider clockwise movements are positive and the direction of the clockwise movement is a positive and anti-clockwise is negative, why we have to consider like that? So that mathematically we can. Now the physical meaning of equilibrium is clockwise movements equal to anti-clockwise movement. Then it will be in equilibrium. How to quantify it? In the language of mathematics you have to come out. For that we have to assume that clockwise movements are considered as a positive, anti-clockwise movements are to be considered as positive, as vice versa. Clockwise movements are positive means anti-clockwise movements are negative. So the way we have to consider, that is the gap. So that is the transition. We are converting the physics into mathematics by using, that is what significance. The clockwise movement are considered as a positive, anti-clockwise movements are considered as a negative. With that assumption, with that sign convention, what we are going to do it, we are converting into mathematically that movements of a force. such a way that if algebraic sum is 0, algebraic sum of the moments equal to 0, that means what is the meaning? The clockwise movements are being cancelled by the anti-clockwise movements. The clockwise movements effect is cancelled by anti-clockwise movements. The clockwise movement here in this case, the pivot at O, F1 into D by 2, if F1 equal to F2, same force or same load, this F1 into F2 are equal. Then what about the point O, F1 equal to F2, what will happen? The action, reaction. From that concept, if you saw measuring the scales, in olden days, if you consider there is the measuring instrument, yes, to purchase vegetables, here the needle will be there. The person used to hold. If F1, the load, how many vegetables are here, they will keep the weight, 1 kilogram weight. So 1 kg weight equal to equal weight of vegetables. Equal weight of vegetables if you keep it. How can we know it? But the both should be what? Equal, same level of height. That means, what is that meaning? The moment caused by vegetables, your brinjal, and the distance d1, and the moment caused by 1 kilogram weight, distance d2, both are balanced, equal. Then that means the quantity kept, the vegetables are equal weight of this quantity, 1 kilogram. That means, what is that meaning? F1 into D1, here about this point, in this case, that equal to, this F2 into D2. Then where it is a pivot point where he will hold that person. Okay, that's what here F1 into D1 equal to F2 into D2 should be there. That means he is applying the concepts of what? Law of movements. That is what? Sigma m equal to 0. The clockwise movement and anti-clockwise movements are balanced. Balanced means cancelled. Then what is the effect? The moment equilibrium. There is no effect of the moment. Momentarily, it is in equilibrium. It is stable. So there are three types of equilibrium actually. That is horizontal equilibrium, that is sigma fh equal to 0, and vertical equilibrium, sigma fv equal to 0. And the third one equation is the sigma m equal to 0, momentary equilibrium. So these are the three types of moment equilibrium cases. So in this session, again, we have studied the concepts of what is moment of a force, how the moment of force is applicable in daily life, purchasing the vegetables, or opening the doors, or tightening the bolts, or tightening the screws. This moment concept is very, very important in the fields of mechanical engineering, aeronautical, and civil engineering. The structures, bridges are made of beams with the different sections. These bridges are joined with the help of nut and bolts. To tighten the nut, unscrew the nut, what is required? The concept of moment of a force is required. That's why this moment of force is very, very important for engineers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.